So I'm a programmer. When I want to relax, I usually play video games. But also I like to try different things and play around with some softwares. And recently I haven't been doing much programming for my games since I've been doing like marketing and release stuff. So I figured why not relax a little bit and try to come up with a 3D third-person shooter in Godot and see what I can make. I actually have quite a bit of experience making third-person shooters, but I've never done it with Godot, so I figured while I'm learning, I might as well share a bit of wisdom with you. So the first thing I'll do is create a new project in Godot, and we're going to call it maybe TPS YouTube. And once we have the basic folder structure for Godot, we can go ahead and create my own personal structure of how I like to organize my file. That means having a data folder, a scripts folder, and a scenes folder. And in the data folder, I'm going to create a source folder. And this is going to be to put all the Krita file or the Photoshop file or the stuff that is not going to be used inside the game, but I want to keep inside the project. And I'm going to create a .gdignore file here to tell Godot that I don't want him to process this folder. Now, I'm not an artist and I'm not an animator, and this isn't a Blender tutorial, so I'm not going to show you how to create animations and models in 3D. I'm just going to go to Mixamo, which is a website where you can download free animations and models for your games, and I'm going to download a couple of those for my game. Now, I started with this TPOS YBot as a prototyping model, and I downloaded a bunch of animations. I wanted a few animations to try to prototype a couple of different interactions between the animations, so I went with a walk cycle here, I went with a running cycle here, an idle loop, and then I wanted some one-shots that I could blend with everything else, so I downloaded this jump animation and this second running jump animation, and I put them into my source folder. Now, if you notice, some of these animations have a checkbox called in place. This is because there's kind of two ways of moving a character with its animation. One is moving it in the code, and one is something called root motion. So when you click in place, you'll see that the character has the same animation, but he's not moving. And when you remove the in place, then he's moving. That's because the movement is actually baked inside the animation. And from all the years I've worked in the game industry, we've always used root motion for character movement because this is much easier to make sure that the character is not going to be slipping on the floor, and it looks much more anchored inside the world you're making. The problem is, downloading these animation from Mixamo, the root motion is actually the hips bone. And try as I may, I never managed to get it to work in Godot. I tried many things, believe me, but there was always something off with the animation. Thankfully, I found on itch.io this Godot Game Tools plugin for Blender that will not only add the proper root motion that Godot needs, but it's also going to be able to merge all the animation from different FBX files from Mixamo into a single animation player for Godot to use, which is really a big time saver. So the way that works is that you're going to download this plugin and boot up Blender, delete all the default items, and then go into the edit preference and click on the add-ons. And if you've downloaded the file on itch.io, you can just go click install, select your file, and it should show up in the file as Godot Game Tools. Make sure it's checked, and then if you click N, it's going to pop up the property dialog, and you're going to have the Godot Game Tools tab here. And if you go into character utility armature, you can initialize with the characters you downloaded. So let's say I load the first T-pause of my character. He's going to show up here in Blender. And then what you can do is join animations and then go and select all the other animation for your character, like the idle, the jump, the running jump, and the walking, and then click join. And after a little bit of time, all these guys are going to be loaded inside Blender. Now, if you go into the root motion section, I'll make that a bit wider, you'll see that there's this apply root motion to all that you can check. And then if you look, it's going to create this root motion bone. and it's going to base it on the hips bone. And this is already configured for using Mixamo's setup, so you don't need to change anything. And you can just click Add Root Motion. And once this is done, you can go into the Export Character, and you can choose your folder and just give it some name, for example, Ybot, and export the character as a GLTF file. Now we can go back into Godot and select our project we created before. And now we need to create our test scene that we're going to play where our character is going to move. So for this, we're going to create a new 3D scene, and we're going to call it main. And I'm going to save this scene inside my scene folder. Now we need to create a bit of geometry for our character to interact with. So the way I did that is I created an empty spatial node that I called level, and inside of this I created a bunch of mesh instance. This is nice because you don't really need to model anything. I just created these cube mesh and I sized them. So for example, I put the floor as 0.5 height and 100 in by 100. And as you can see, I already kind of have a floor. Now, it's nice to have a bit of texture so that you have a better idea of how far your character is moving or how quickly your character is moving and all that. So to do this, I went into, again, some free texture pack that I found on Kenne's website. There's this prototype texture pack with a bunch of different colored texture with different grids that you can use. And I downloaded this into my data folder inside a texture folder. And now that we've downloaded that into our project, we can take our mesh instance, and in the material section, we can create a new spatial material, and in the albedo, we're going to load one of the texture I just downloaded. Let's say for the ground, we can go with the dark ground and just put this like this. Of course, now the UVs are mapped to 1:1, but if you remember our cube, we stretched it 100 unit long, so I can just scale this by 100 unit. And so now we have this nice grid pattern that we're going to be able to use as a debug level, or what people call block mesh. Now, of course, we want this to be physically interactable, so to do this, we need to add a static body. And the static body needs to have a collision shape. So we're going to add a collision shape. And this shape, again, we're going to make it a box. And we're going to set this box as the same size as our floor that we just created. So 100 like, 50 like this, 50 like this, and 0.5 and 50. So now we can see that the collision is fitting our box that we created as the floor. Now, of course, it's nice to have other stuff to interact with, so you can create just another bunch of cubes with the mesh instance to, create some interest in your level. I mean, it doesn't even have to be cube, it can be cylinder or prism or whatever. So, but I'm just going to stick with cubes for now. So this will be just like a default cube like this. I'm going to, again, apply some material to it. Like, it doesn't need to be anything pretty, it's just to give it a little bit of color and function. And now that we have this cube here, we are going to add another physics material to it. And we can actually just duplicate this to create many different boxes, and I'm going to scale them a little bit just to have different size of boxes. It doesn't even need to be like scaled uniformly, and I can have this be like 100 unit long. Maybe that's a bit too much, like 20 unit long, and I can put it a little bit inside the ground to make it a little bit lower. And one thing that's nice also is that you could always create a mesh and rotate it a little bit so that it becomes a slope, because in these kind of game, slopes can often be a source of problem. The character is going to slide down a bit, or when he falls down some height, you want to test the animations. So it's a good idea to have a slope so you can test like different, behavior when you're climbing stairs or stuff like that. So now that we have our level, it's time to create our player. For this, we're going to create a new scene again. We're going to this time make the root node a kinematic body. And we're going to put our bot inside this kinematic body. And I want it centered, so I'm going to reset its transformation. Now, if you look, inside this, we have the animation player with all the animation we exported from Blender. But we're not going to be directly using the animation player because we want to have a little bit more control over how the animations are played. So for this, we're going to be creating an animation tree. And in the animation tree, it's pretty easy. There's a couple of things we have to set up. First, we have to tell the animation tree which animation player it's going to be driving. So it's going to be driving this animation player. And like I mentioned before, we're going to be using root motion. So in the root motion section, we have to assign the root motion bones that Blender added. As you can see, under the root motion, there's the hips from Mixamo, and this is the one we added from Blender. Now you can go into the tree root and you can add a node state machine. And you can add inside the tree all the animation that are from the character. Well, actually, we don't need the T-pause. Now, if you want to test it, you can just click on the animation tree and make it active. And you can click the little play button to see if everything is working fine. Now, one thing to be careful is don't go playing animation in the animation player and in the animation tree at the same time, because that's going to create some very weird issues. If you want to test an animation in the animation player, just uncheck the active from the animation tree. And for now, what we're going to do is set up some transition between these animations. So for now, I'm not really interested in the jump animation, but I want to set up the walking, the running, and the idle loop. And I'm going to rename them so it's a little bit easier. We're going to call it idle, running, and walking. And to set up the transition, you click the little transition here, and you can just drag and drop between the different states. And in our case, we want all transition between all animation. There's no like going to walking before going to running or something. So we just want transition everywhere. And if you click on a transition, you can set up a couple of different properties. But for now, the only thing we really want is to add some X fade time, which is going to be a time of transition between the two animation so that Godot can blend these animation together for a little bit. If you had perfectly synced animation between each other, you could probably do with instant transition, maybe select the sync here. But since I downloaded from Mixamo a bunch of different animation and I'm not quite sure how it works, I'm just going to blend and it's going to look, I think, pretty alright. You have to do this for all the transition that we just created. Now you have to be careful because this transition means that even when you go back to the idle state, the character is going to be moving a little bit while it's transitioning. And that might be fine for some, but it might also be an issue if you want really snappy controls. That's something to see for later. Now, of course, this is a kinematic body and it's complaining that it doesn't have any shape or collision shape. So we're going to, again, create a collision shape here for the rigid body. And we're going to make it a capsule. And we're going to fit it to the character's body by rotating it a little bit and then playing with the size. I mean, it doesn't really matter. It just needs to fit approximately. I think it's not so important for now. Maybe eventually you'll want like a more complex hitbox if you're doing a shooter or something. But for now, the capsule for movement is going to be plenty enough. If you want to reset it, you can just go into the animation player and select the first frame. So this way your character is going to be centered where it should be. And you can see that fits pretty well. So we're going to save this in our scenes as the player. And we can go back and add the player into our level. Now we can go back into our player, and actually one thing I forgot is to set the idle animation as the starting point for the state machine so that the character is always going to start in the idle state. Now the next thing we need to do is add a script to the kinematic body to make our player actually move. So we're going to save this as player control. And the only method we really need right now is the physics process. Because it's a kinematic body, it's really important that we move the character in the physics process. Another thing we're going to need is a reference to the animation tree so it can switch the animation state of the player. So we're going to export a notepad here that we're going to call the animation tree. And we're going to have an onReady var that's going to be the anim tree. And technically we should be able to assign the animation tree to our anim tree here. And we can go here. For now, all I really want to do is make sure that when I hit the key, the animation is going to be able to travel from one state to the other. So I'm not going to get into all the control schemes for now. That's going to be for another video, because otherwise this video would be way too long. So all I'm going to do for now is add an if input that is action pressed. And for now, we're just going to put whatever, say UI select, which is going to be the spacebar. And then we're going to say, if you look in the animation tree, here you're going to have the parameter option. And these are created dynamically based on what you have in there. And if you look, it has this playback. And if you hover over it, it's going to tell you the path to this parameter. So in this case, it's parameters/playback. So what you can do is just do anim tree and do parameters/playback. And this is going to give you access to the state machine that we have. So we can just do travel and go to the running animation. And if no key is pressed, then we can just go back to the idle animation. And with just that, if we go back to our main scene and maybe set up some static camera just so we can see something. So I'm just going to position the camera a little bit so we can see the player. Oops. And if I hit play and I hit space, then the character starts running. And if I release, then the character stops running. Though he's running in place and he's not very physical yet. So let's fix that. If we go back into the script, if you remember, I talk about the root motion. The thing is Godot is going to take the information in the root motion bone and it's going to keep it and not apply it to the model. So it's our responsibility to apply the root motion to whatever it is we want to move, because maybe we don't want to move just the model, like in our case we want to also move the collision from the kinematic body. So to do this we need to go get the root motion transform, and we're going to do this by going root motion equal anim tree that get root motion transform. Now a transform has a translation and a rotation, but we're not really interested in the rotation, we really just want the translation. So to apply the translation, we're going to get it as a velocity from the root motion transform. And then we can pass it to the move and slide method that's going to move our character rigid body. Now if I do that and I test in the main scene, now when I hit play, the character should move forward. Of course, if I move him up a little bit and I hit play again, you're going to notice that he's kind of floating in the air. That's because we are responsible also for applying the gravity. Now the gravity is an acceleration, and what we're passing to move and slide is actually a velocity. Which means we're going to have to keep the gravity acceleration from one frame to the other. So we're going to add a new variable called gravity, and we're going to initialize it to 0. Now, I don't want to keep adding the gravity all the time, because when the character is on the ground, actually, the gravity should just return 0. So what I'm going to do is that the kinematic body in Godot already has a very useful function to test if something is on the floor. So I can do if is on floor, gravity equal vector 3.0. Else, we're going to add a bit of gravity. And of course, this is a vector tree because you could have gravity in a way you want, but in our case, it's just going to be in the y direction. And we're just going to use standard gravity like this. And in the end, we're going to add our gravity to our velocity. And just by doing this, normally, when we go back in our character, he should be falling on the floor. And actually, if I move my little slope, turn it around, up. So that's working pretty well. So with just this, we already have a basic animation system working. We know how to import new animations, set up the state machine and everything, and we have some physics going for our level. Now the next step is going to set up a camera structure that will allow us after that to follow the character around and making turn and jump. But this is going to be for the next video. So see you all in my next video. Bye!